mechanism. Breakdown mechanism. What is mean by breakdown mechanism? The PN junction diode, அப்படிங்கிறது நமக்கு தெரியும். The minority charge carriers and majority charge carriers உண்டாகும். So P-type semiconductor material emit has a large number of holes. So holes are the majority charge carriers and electrons are the minority charge carriers. In N-type materials, N-type semiconductor materials, that electrons are the majority charge carriers, holes are minority charge carriers. So here PN junction diode, so has a two types of breakdown. One is the Zener breakdown, another one is the avalanche breakdown. So that Zener breakdown and the avalanche breakdown, that mechanisms are used in the to maintain the theoretical current and the and it is used for the electronic devices. The first one is Zener breakdown. So Zener breakdown means PN junction diode. You know that it has the charge carriers. So charge carriers, number of charge carriers depending on the P-type and the N-type semiconductor materials. So it has at a particular voltage, it can conduct like a conductor. So it conducts large amount of current. So in PN junction diode only works in the forward bias condition. So forward bias condition conducts the energy. But in a reverse bias condition, this does not current is flowing through the PN junction diode. So here Zener breakdown, that is Zener breakdown is used for the current flow in the reverse bias condition. So junction has a very narrow depletion layer. Why? Because the Zener diode is mixed with the impurities increases. It contains large number of charge carriers. The Zener diode is heavily doped. So ordinary diode is lightly doped, but Zener diode is heavily doped. So it has a large number of charge carriers. So Zener diode works in the reverse bias condition also. So it has a very thin layer of 10 to the power of -6 meter. So here strong electric field is produced between the thick layer is 3 into the power of 7 volt-meter inverse. So here when when the electric field is applied, that is current is applied, that strong electric field is produced in the lattice path. So it produces the Zener. Very small amount of current is applied in the reverse bias condition. Large number of charge carriers are produced. That it is heavily doped. So it has a very low resistance in the breakdown region. So it conducts a large amount of current. So because it has a large number of electrons. So the lattice due to strong electric field, the internal field emissions are the field ionization called. The electric field required for the order is 10 to the power 6 volt per meter. So it's called the Zener breakdown. Zener breakdown is different from PN junction diode because PN junction diode is it has less number of charge carriers, but Zener diode has a large number of charge carriers because it is heavily doped. PN junction diode only works on the forward bias condition. It does not work on the reverse bias condition. But Zener diode or Zener breakdown, it works in the reverse bias condition. Next thing is avalanche breakdown. The avalanche breakdown means that when the PN junction diode we are lightly doped. That means it has less number of charge carriers. Initially we are applying that electric field. The charge carriers are increases inside the PN junction diode. When strong electric field is produced, what will happen? The charge carriers, that means electrons and holes are accelerated. That accelerated charge carriers are collide with the another. So accelerated charge carriers are collide with the another atom. So covalent bond is broken. Again, that electrons are produced. So gradually the number of charge carriers are increases. Finally, it produces very large number of charge carriers. So that's called avalanche breakdown. When you draw the graph between the charge carriers and the flow of current, you will get the slope like this. That slope. Avalanche உங்களுக்கு தெரியும் நினைக்கிறேன், ஊட்டில ஒரு மலை செங்குத்தா இருக்கும். So அந்த மாதிரி கிடைக்கும். So suddenly it increases very large number of charge carriers. So that type of breakdown is called avalanche breakdown. So two types of breakdown. One is Zener, another one is avalanche. Zener breakdown occurs only in the Zener because it is heavily doped. Avalanche breakdown occurs in the PN junction diode. So that PN junction diode, now we are going to see the Zener diode. Zener diode means PN junction diode is lightly doped. Here, Zener diode is heavily doped. Heavily doped means it contains large number of charge carriers. You know that atom, only one atom has the only one electron. Suppose we are adding the trivalent or pentavalent, the charge carriers are increases. Heavily doped means we are adding large amount of impurity atom. So definitely it contains large number of charge carriers. So when it has a very large number of charge carriers, definitely the conductivity of the Zener diode also increases. நிறைய எலக்ட்ரான் இருந்தா என்ன பண்ணும், நிறைய எனர்ஜி கண்டக்ட் பண்ணும். ஸோ கண்டக்டர்ல நிறைய எலக்ட்ரான் இருக்க அதனுடைய கண்டக்டிவிட்டி இன்க்ரீஸ் ஆகும். அதே மாதிரி தான் Zener diode it contains large number of charge carriers. So contains in reverse bias condition also. That ordinary PN junction diode, it has only less number of charge carriers. So it is only current flow in the forward bias condition. There is no flow in the reverse bias condition. But in the Zener breakdown, it contains large number of charge carriers. So it is works in the reverse bias condition also. So the silicon has a very phase breakdown voltage from 2 volt to 1000 volt. Sir. So this is a Zener breakdown. The Zener diode. Zener diode. The Zener diode is simple circuit symbol is this one. Ordinary PN junction diode, you can see that only straight line is here. But in Zener breakdown, it is like a C. Z bar இருக்கும். மேல ஒரு பெட்டு கீழே ஒரு பெட்டு இப்படி இருந்தா that is Zener diode. இந்த பெண்ட் இல்லாம ஸ்ட்ரெயிட் லைனா இருந்துச்சு அப்படின்னா அது PN junction diode. So in circuit symbol, this one is used in the circuit. Okay, now we are going to study the VI, that is potential current capsules of Zener diode. So now we are going to study the capsule. See the circuit diagram. Diode is connected in the forward bias condition. So forward bias means positive is connected to the positive terminal of the battery, negative terminal is connected to the negative terminal of the battery. So milliammeter is to measure the flow of current, and voltmeter is to measure the flow voltage applied to the potential difference between the Zener diode. Okay, now resistance, that's a lower resistance. So resistance is used to suppose very large amount of current is flowing through the diode, it will rupture or it will break the or it will damage the Zener diode. That's why we are using the resistance. So the when you are reversing the resistance, it allows only the limited current through the Zener diode. So it is a forward bias condition because positive, negative is not there. So it is in a forward bias condition. When gradually the potential is increases, the corresponding flow of current also not there. See this graph. When flow of current is gradually increases, the flow of current when potential is increases, the flow of current also gradually increases. At a certain value, the flow of current is increases enormously in forward bias condition. Where it flows in a maximum current, it's called breakdown voltage. So here the breakdown voltage, or it's called knee voltage, or threshold voltage, or cut-in voltage, is all the name for that voltage. See here, the knee voltage. What is the breakdown voltage for the germanium and silicon? 0.3 voltage for germanium, 0.7 voltage for silicon. So in that particular voltage, the germanium and silicon contact the current. It is a forward bias condition. In reverse bias condition means everything is same. Only we are changing the polarity of the Zener diode. See here, positive is connected to positive. Now here the positive is connected to negative, negative is connected to positive. So reverse bias condition. Forward means same polarity, reverse means opposite polarity. So reverse bias condition. In reverse bias condition, again the flow of current, that applied potential is gradually increases. The corresponding current is not there. When you draw the graph between the voltage and the current in a reverse bias condition, see that here gradually the flow of current increases. At a particular voltage, the flow of current increases maximum. That particular voltage is called Zener breakdown voltage. It's called Zener breakdown voltage. Constant Zener diode voltage. See, up to, for example, suppose it's a 6.7 means this 6.7 is the Zener voltage. Above that voltage, the current increases more than 6.7 voltage. So whatever may be that the flow of current only increases in that particular voltage. So it is behaved like a conductor. It is working in a reverse bias condition. So that is a Zener diode. Okay. So next thing is Zener. Then you can see that application of Zener. So what are the applications of Zener diode? That application of Zener diodes are, first one is voltage regulator. The Zener diode is voltage regulator. You know the voltage regulator. Voltage regulator nothing but the stabilizer. You are using in your home. That's for used for PV, fridge, like that. So it is used as a voltage regulator. Next thing is calibrating voltages. So we can measure the voltage by using this Zener diode. Next thing is provide fixed reference voltage in a network biasing. Network biasing means we send when the current in a particular current should not exceed or lower that limit. So we can maintain the same voltage. So in that process, we can use the Zener diode. Next thing is protection of any gadgets against damage from the accidental application of excessive voltage. That is the stabilizer. I already told you that. So it is used in the stabilizer. So now we are going to see the voltage diode as a voltage regulator. So that is the application of the Zener diode. So see that Zener diode as a voltage regulator. So the Zener diode is here. So it is works in a reverse bias condition. So V is that. So it's the input current and output current is taken from the load resistance. So Ri is the input resistance. So that voltage regulator means when the input current and voltage is increases or decreases, that Zener diode must maintain the same current and voltage. That is the principle of the Zener diode as a voltage regulator. So now you can see that suppose that voltage current that voltage is increases. So when the voltage is increases in this circuit, input voltage is increases. So what happens when the voltage is increases? The flow of current also increases. When current increases, the current is dropped across the resistance Ri. So again we can maintain the same current. Suppose that current is increases. That current increases means that potential is decreases. When potential decreases, the flow of current in the Zener diode also decreases. அப்போ current increase ஆகுதுன்னா voltage குறையும். Voltage குறைஞ்சா flow of electrons வந்து Zener diode குறையும். So it can decrease the flow of current in that circuit. Or suppose that current is decreases, voltage increases. So current is increases by the Zener diode V is that. Or the current is voltage decreases, the current increases. When current increases, then voltage decreases. It is slow down. It is decreases the flow of current in the circuit. So input current I, that I is the current passing through the Zener diode. V output. So IL is the load resistance of current. So like that, when the current is flowing through the circuit, it will maintain. So flow of current I equal to IZ plus IL. So the total current we have to add that IZ and IL. So depending on that IL and IZ, that output current we can take out from the load resistance RL. But these two values are depending on the input current and the voltage. So it can maintain the same current and voltage works in a reverse bias condition. So this is the Zener diode voltage regulator. As Zener diode is a voltage regulator, it can maintain the same voltage and the